Because today we're going to start using congruent triangles. Okay? So, and this I believe is the end of section 3, or actually part 2. So I believe this is the last section before the, yes. So we'll do this. Tomorrow we'll go over the homework. We'll review. So you'll have a test, I guess on Monday. The extra credit's already up online, and it's on your study sheet, so you know what it is. So you can get a jump on that, especially if you just do a couple sections. So we're going to use everything we've learned about congruent triangles in order to prove other things now. So now we're sort of putting everything together. All right, so the first thing we want to know is, once you've proven that two triangles are congruent, then once you've done that, then you can start using their corresponding parts to prove other things. So, for example, if you have two, for the homework last night when we were talking about it, Molly, I'm looking real quick at what was the number we did that we were talking about, the perpendicular ones? Number 12?
We don't have 12.
Was it 11?
11? No, we had a couple that were perpendicular that you were asking about.
Number 5.
Oh, it was number 11.
It was number 11. Okay. So we said that just because those lines are parallel, AC and BC, that didn't make them congruent, which is true. So you don't know that AC is congruent to BT because they're parallel. But once you've proved that these two triangles are congruent, which they are, now you can say, it's taking it a step further. Now you can say that BT is congruent to AC because of corresponding parts of congruent triangles are congruent. CP, CT, C. Okay? And so that's sort of where the first part of this section goes, is prove some things are true, prove two triangles are congruent, and then, once they're congruent, all the other corresponding parts are congruent. So let's do one. So I'm given that AB and CD bisect each other at M. Okay? So let's do some statements. And reasons. All right. So the first thing we can say is that AB, we got to state the given, right? AB and CD bisect each other at M. Okay. And so the first thing I know is what? The AM is congruent to BM, and that's because of what?
Definition of a midpoint.
That's the definition of a midpoint.
Definition of a bisector.
Oh, did I put the wrong thing?
I think it's bisector.
What's that?
Is it bisector or midpoint?
I don't know.
They use midpoint in the.
Well, M is the midpoint.
They use the midpoint in the book, but okay. The definition of a midpoint.
Yeah, that's why.
Okay. All right. All right. So we know that AM is congruent to BM. So the first thing we're trying to find is that these triangles are congruent. And we're going to do that by one of our three postulates that we've learned. So you see that you have a side there. So where do we go next? Well,
Angle.
what's that?
Angle, right? Because if we have a side, you can find an angle.
Okay,
Side,
what-
angle, side.
And what sides are you going to have?
Is this a me answer?
What's that?
Am I supposed to answer this?
Sure.
Okay. So angle MCB is congruent to MDA.
All right, say that again.
MCB is congruent to MDA.
Because
They are alternate. Wait,
well,
no.
you don't know anything's parallel. You're trying to prove that things are parallel.
Oh, we are?
Well, that's what it
Never mind.
says.
I take
Prove
that back.
AD. You want to prove
I take
that
that
this
back.
is parallel to this.
I was like, wait a second, these are parallel. I forgot they were parallel. My bad.
Is there a way to prove DM is congruent to MC?
Well, how about this? How about this? M is the midpoint. Someone said
DC. Right?
M is the midpoint of what?
Of DC. Or
DC.
No, it's
AB.
Maybe.
I don't know.
AB, because it can't.
Of AB and CD. And what's the reason that
How
what?
do you know it's and CD?
How do you say? Wait,
Oh,
what?
C
It
and
gives it up to your given, right? That's your other given, right?
Why'd you say AD?
Because it says it there.
Did I write?
Oh, it's AB.
Oh, did I write the wrong
And
one?
it's
I'm
midpoint
sorry.
of it.
Yes, I'm sorry. That was
Oh.
AB. I just wrote.
Okay.
Sorry. What did I do there? And tools. What's my reason for? Or I'm sorry. Well, my reason is it's given, but what's that going to tell me?
That will tell you.
C.
C is equal.
Right.
That tells you what?
CD
Or
is the
CM
same.
is equal to DM.
Yes. CM is congruent to DM.
So then
So
we have the
then-
two two
Right.
sides and you just need the angle.
CM is congruent to DM. And what was the reason for that?
Side to side.
What?
Wait, what?
That's
I'm asking what the
definition.
reason is for that.
Definition of the-
Definition.
Or
of
bisector.
Bisector.
Definition of a midpoint, right?
Oh,
It's the same thing as we
Yeah,
did before, it's just we did the other line, right?
Can you change this? Not change it. So then, basically, yeah. Pure
Okay. So, in order to prove these triangles are congruent, what do you have to find? What else do you have to prove?
One angle. And I say.
One angle or
Another side.
another side. Okay. And what angles can you prove are congruent here?
Vertical angles.
Which is what? Give me
Which
the
is
angles.
M. Oh,
Wow, now you gotta be
AMD.
careful.
AMD
Yeah.
and that other.
CMB.
Yeah.
If you're somebody who does that and on tests before you've gotten it wrong because you weren't specific enough with your angles where you had M here, and so that's why you're doing it every time. That's fine. Do it every time because you're not wrong to call when it's here. This is just angle D because it's not ambiguous, but it's not wrong to call it ADM. So if that's a mistake that you make and you want to use 3 letters, that's better than getting in the habit of calling them 1 letter and then you get to a place like M and you don't know what you're talking about. So
Okay. Okay.
when I told you before to use 1, you could, but if that's a mistake you're making, you're better off naming it with 3, and then the more specific you are, you won't get it wrong. Okay, so I'm sorry. What angle did we call it?
AMD.
AMD, and that's congruent to angle
BMC.
BMC. And
Combo.
what was the
Definition.
Side angle side.
vertical angles are congruent, right?
Oh, yeah. My bad. I forgot we haven't proven yet.
Okay. And so now what do we know? Now that you have 2 sides and included angle, what do you have?
The triangles are congruent.
Yeah.
I forget this.
Triangle. MDA
MDA. Now be careful. Now be careful. Make sure you're
is
corresponding.
congruent to triangle
MDA.
MBC. No, MCB. Which way did I go?
You went first. You went
Down.
MDA.
Okay.
So now what are you gonna do?
MCB.
MCB. Good.
So, do you know what the MCB is?
And what are you gonna call that?
Side
Michael?
angles.
What's the postulate?
I say yes.
SAS
I
postulate.
don't know what the MCB is. No, is there a combo?
Okay, but keep in mind, I still haven't proven what I want to prove. What do I
No.
want to prove?
That AD and BC are parallel.
So I want to prove these are parallel. So how will I do that?
You
Well, you can't just say they're parallel. How would you prove that? This is where I was getting at. So now you've proved two triangles are congruent, but now what?
Well, if those two sides are congruent,
Then those two sides.
then they have to be congruent because
We know they're congruent, but why does BC and AD have to be parallel? That's what you're trying to prove. That this line and this line are parallel. You prove that they're congruent, but that doesn't prove that they're parallel. How do you prove?
Distance from this.
Does that have to do with DMC and A?
DMC?
No.
No.
Lines.
No.
When you take
All
when
right,
you pivot it.
All right, let's think of it this way. What do you know about angle A and angle B?
They're the same. Alternate interior angles.
Well, what do you know about them?
They're
They're congruent?
Two
Yeah.
lines cut by
Angle A and B are congruent?
yes.
So 7, you could say angle A is congruent to, what did I say?
Angle B. I think.
And what's my reason for that, Jordan? No, that's not true. Why is A and B congruent? We've proved these triangles are congruent, so through CP, if those two triangles are congruent, all of the angles and sides are congruent, right?
Yeah.
So that's true because of CPCTC. Now, because you have those two angles, which would be alternate interior angles of this transversal and those lines, now you can say that A, what was the letters? AC, AD is parallel to, what was it? I take this one. Terrible short term. CB. And what's the reason for that, Molly?
I don't know.
Two parallel lines are cut by a transversal. The alternate interior angles are congruent.
So that,
So if you have two congruent angles and you have a transversal, that means those must be parallel.
Okay, so they have to be parallel to that.
Yeah?
But how would you know that A and B are congruent? I don't understand that.
Why A and B are congruent?
Yeah.
Because you have two congruent triangles. So if you have two congruent triangles, all the corresponding parts are congruent. So once you have that they're congruent, now all the sides are congruent, all the angles are congruent.
So A and B because of corresponding?
Corresponding parts of congruent triangles are congruent.
Okay. Okay.
And so I'll just write if parallel lines cut by trans.
Not parallel lines, just two lines.
Oh, if two lines
Yeah,
cut by transversal are if two congruent lines
Are you?
are cut by a transverse.
no, if just two lines are cut by a transversal such that the alternate interior angles are congruent, then the lines are parallel.
Alright. So if two lines are cut by transversal,
Mr. Arnold shaking his head.
and then
Harry and Culver, what are you guys trying to do? Learn something extra? Get ahead of your neighbors? That ain't fair, is it? Come on.
What's that?
Somebody's got
Oh, I'm still recording. Good, yes, I'll turn it off.